Example 1. The function f of x equals x cubed minus 4x squared minus 4 has a root alpha that lies between 4 and 5. Part A, show that alpha lies between 4 and 5. So let's start off with part A. Showing that alpha lies between 4 and 5 means we have to use the change of sign test. I'm going to evaluate the function f of x for f of 4. So I get 4 cubed minus 4 lots of 4 squared minus 4, which gives me f of 4 equals minus 4. I'm then going to evaluate it for f of 5. So I'm going to substitute the value of 5 in, so I get 5 cubed minus 4 lots of 5 squared minus 4, which gives me, when I put this into a calculator and evaluate it, a value of 21. So at this point I have shown there's a change of sign, so I must state this. Therefore, since there is a change of sign, for f of 4 and f of 5, then alpha lies between those two values as required. Okay, so let's have a look at part B. Part B says show that f of x can be equals 0 can be rearranged to give this equation here. So we start off with x cubed minus 4x squared minus 4 equals 0. So what I'm going to do is I'm going to add the 4x squared to both sides, and I'm going to add the 4 to both sides. Now the reason I'm doing this is I can notice that on one side we've got an x, and on the other side we've got the 4's. So I'm just going to do that and see how I proceed from there. So I get x cubed equals 4x squared plus 4. Now if I wanted to get this to x, if you notice each one of these powers, the powers dropped by 2 here. X to the power has dropped by 2 here, and this is 4x to the minus 2. So if I divide both sides by x squared, what I get left with is on the left hand side I get left with x. I then get equal to 4 plus 4 over x squared as required. Okay, so let's look at part C then. Part C says using x0 equals 4.5 with the iterative formula, xn plus 1 equals 4 plus 4 over xn squared. Find x4 correct to 4 decimal places. So we're going to do x0 is 4.5. I'm just going to put this into my calculator and evaluate it. So I'm just going to list them here to x2, x3, x4. So as I'm giving an answer to 3 decimal places, I'm going to work to at least 4 decimal places. So once I put in 4.5 into my iterative formula on my calculator, we get 4.1975. And there are other parts of that sequence. I'm just listing up to 4 decimal places. Put it in again, and I'm going to find that x2 equals 4.2270 and that's with a little bit extra in the end. x3 is 4.2239, and then x4 is 4.2242 ... which when rounded to 3 decimal places is 4.224. Okay, so let's look at part D finally. Part D says show that alpha equals x4 correct to 3 decimal places. So what we're saying is actually alpha equals to 4.224 to 3 decimal places. To show that this is corrected to 3 decimal places, I'm going to take the upper bound and lower bound of what would round to this value and use a change of sign test. So I'm going to take the lower bound. So if I do f of 4.2235, so that I do 4.2235 cubed minus 4 lots of 4.2235 squared minus 4, so that I can find f of 4.2235, evaluate this in my calculator, and we get an answer of minus 0.013 just given the first 3 decimal places there, because really I'm only interested in the sign. So that's a lower bound value. Now if I do the upper bound value, what I'm expecting here is to get a positive answer. So 4.2245 equals 4.2245 cubed minus 4 lots of 4.2245 squared minus 4. And if I stick that into my calculator carefully and evaluate that, what we come out with as an answer is 0.007. There are some other digits, but really we're just interested in the positive and negative. So what I've shown here is that the upper bound and lower bound for this value that we've rounded to here, there's a change of sign. So alpha must lie between those upper and lower bounds, and so then alpha must round to 4.224 to 3 decimal places. So that's what we're going to state. So we're going to say, therefore, since there is a change of sign, and remember that these statements are really important because this is worth a mark stating what we found. So we found a change of sign between f of 4.2235 and f of 4.2245. That means that alpha must lie between 4.2235 and 4.2245. So that alpha is equal to 4.224, correct to 3 decimal places. Okay, well I hope that answer made sense and you was able to follow what we was doing there.